Hey, I'm Leigh Halliday, and in this video we're going to work on a really cool demo where we combine React with Google Maps, with directions, with Three.js. And we're going to combine them all together to create this demo here, where we have directions between 27 Front Street to 75 Yonge Street in Toronto, and then we animate a car in 3D along that route. And we can zoom in and see the car in detail moving along that path. So that's where we're going to end up, but we're starting here, just a blank screen that says the word app. So first things first, if we pop over to the code, we need to get the Google Maps script loading on the screen. And we're going to use the wrapper import for that. And you'll see there's a number of other imports here, but we'll talk about each one as we use them to not introduce them all at once. So right here, we need to first load the Google Maps script, and we do that using wrapper. And to wrapper as a prop, we have to pass the API key. Now, API key I'm storing in an environment variable in .env.local, so we will copy this map API key, and we'll do process.env and then paste the key. So inside, as children to this wrapper component, what it does is it renders what's inside of this once it has loaded the script. So what do we want to load when the script is ready? We want to render the map. So we'll call my map like this, which doesn't exist yet, but we can go and create it below. Just like that. And in my map, we need to first render a div that the map will then be put onto or attached to. So we'll return a div, and this div can be self-closing because it actually isn't going to do anything, but we need to attach a ref to this because that's how we're going to sort of point Google Maps to the actual DOM node. So because we're using a ref, we need to set up that here. So we'll say const ref is use ref just like that. And when this renders, it will attach this div to this ref so that we can pass that to Google Maps. Last thing I need to do is I'm going to attach an ID of map to that. Why? Because I have some styles set up that will make it 100% width and 100 VH height, so it fills the whole screen. So it's going to render through once, that will attach the ref, and then we'll create a use effect hook. So this runs after the first render. And inside of this, what we're going to do is basically create an instance of the Google map itself. So we're going to store that in state. So we'll say map and set map in state, and we'll say use state hook like that. So then we can come below and we can say set map, and what do we want to do is we want to create a new instance of the Google map. So we'll say new window.google.maps.map, and then here we can pass two things. So we need to pass the ref to the actual div, so ref.current, and then we need to pass map options. Now you might have saw up here that I've already set up our map options. So we'll pass them in, and then we'll just quickly talk about what they are. So the map ID, this is important because anytime you're using Three.js or WebGL overlay with Google Maps, you need to have a vector-based map. So I set one up over here in the Google Maps platform, the developer console. Here's my map ID. You can see that it's a vector-based JavaScript map, and I've attached some gray styling to it so that the car we add will really pop out on the screen. So that is also in an environment variable. You need to tell the map where to load at the beginning, so where the center is. So I just placed it in Toronto. I set the zoom to 18, so it's fairly close zoomed in. I removed the default UI, and then I rotated the map by setting its heading, and then I tilted the map by setting the tilt here. So if we save this, come back and look at the screen, we have Google Maps loading in Toronto. It's tilted, it's on a heading, and we're good to go on to the next step. So now that we have the map set up, what I want to do is focus on getting the directions between two locations. So for that, the first thing I'm going to do is I'm going to store the route up here in state. And we don't really need this yet, but we will need this when we draw the track onto the map and then we animate a car across it. So we're just going to get this set up now. So route and set route is use state, and it can start as an empty value. And then what we're going to do is come down here and we're going to render a directions component that doesn't yet exist, but we'll go create it right now. So I'm putting in a fragment so that below here, I can say, if there's a map, so map and, we want to render the directions. And two directions, we're just going to pass the set route prop, set route, so that from directions, once they load, we can call this set state function so that we put the route up here in the state, and then we'll be able to later use it on for animating the car. So we save this. If I were to look, we're going to get a big error that says direction is not defined. That is true, so let's fix that. So we'll come down here and we'll say direction. Remember, we're going to be receiving set route. And then in here, inside of the route, inside of the direction component, what we're going to do is set up two pieces of state. Now, for this demo, we don't actually need state for this, but I wanted to set it up in the future if somebody wants to take this and expand it to make choosing the two, the origin and the destination, dynamic. We're just going to hard code them in this video, but it's set up right, ready to go if you want to attach Google Places to that to allow the user to search between two destinations. So the origin, and that will be equal to use state, and we're going to just hard code this to 27 Front Street East in Toronto. And then the destination will be use state, and it's going to go to 75 Yonge Street in Toronto, just like that. So we're going to return a div, and in the div we're going to display some of the information. So first things first, I need to give it a class name, because if you saw, it's in the top right corner, it's got a black background, white text. So I set that up with a class of directions. And that's over here in the styles global. If we find directions, you can see it's positioning absolute, top right corner, what its width is, padding is, etc. So we'll come back, and then in here we'll put an H2 and we'll say directions. And where are we going? We're going from an origin, and then what that origin is will be the origin, like that. And we're going from the origin to a destination. So we'll put that on the screen, and the destination is destination. Oops. Like that. So if I were to come back, we now see we have the directions here, but we don't actually know how to get from this location to this location. We need to use the direction service from Google Maps in order to get those directions. So what we're going to do is allow that to render, but we're going to use another useEffect hook that will run after the render, and it's going to rerun anytime the origin or the destination change. So in here, what we're going to do is we are going to call a function that doesn't yet exist, but we're going to call it fetch directions. And we're going to pass in the origin, the destination, and then we're going to pass the set route function to this function so that when we get the directions, we can call this, and that will update the route to place it up here so we can later render the animation. So let's go and create fetch directions. It's going to be an async function, so we'll say async function, and we called it fetch directions. And what do we need to pass to it? We need to pass the origin, the destination, and the set route function. Okay, so I made it async because there's a few promises that we need to use in here. The first thing we need to do is basically call the Google Maps service to get to convert this string of 27 Front Street into latitude and longitude, because you always ask for directions between 2 points, but we're starting with a string, so we need to first convert to get the latitude and longitude. And for that, I'm using a package called use places autocomplete, but specifically we're using get geocode and get lat long. So because we need to call this twice, one for the origin, one for the destination, I'm going to take advantage of JavaScript being able to do that concurrently or in parallel by using promise.all. So I'll call promise.all, and we're doing two things here. So we're getting the geocode, so we'll call that function, and we're getting it of an address, and the address is the origin. And then we need to do that again. So we're going to get the geocode of the address, but this time it's the destination. And because this is going to return us two results when they both resolve, what we're going to do is we're going to place them into a variable, and we're going to await for that. And what we're going to call them are the origin results and the destination results. Save that like that. So what this gives us back are two result sets, but there's another function here called getLatLong, where given a result, it will convert that into actual locations or latitude, longitudes. So for that, it's another sort of the same thing. We're going to do a promise.all because it is asynchronous. So we're just going to copy that and then change the variable names. So the first one will be called origin location, second one destination location. And instead of get geocode, we are going to call get lat lng. And what you need to pass to this is one of the results. So they might give you many different sort of options for this address. We're going to choose the first because it's probably the most accurate. So we're going to say origin results, the first one. And then we'll do the same thing down here, and we'll say destination results, the first one. And if we want to see what this looks like, why don't we console.log, because we've been working blindly for a lot of what we've done so far. So we'll pass this here, and then we'll pass the destination location, and we'll see what happens on the screen. There's no error, so that's a good sign to start with. Let's check the console, see what's going on here. So if I pop open this, we have the destination location is this latitude, longitude, and the origin is this latitude and longitude. So it worked. We were able to call Google Maps with two addresses, get results, convert them to latitude and longitude. And now with these 2 points, we can use the directions service, and the directions service will get us the actual route to get from the origin to the destination. So let's set that up right now. And we're going to create a new variable called service, and that is going to be a new google.maps.directions service, like that. And we don't pass anything at the beginning to this, but what we're going to do is we're going to call service.route. And then to this, we're going to pass a few things. So the first thing we're going to pass is the origin. So we've got the origin location, like that. And then we're going to pass the destination with the destination location, like that. And then we need to tell it how we're traveling, because Google Maps, you can travel walking, by bike, by car. So we're traveling by car, so that's driving. So we'll say travel mode, and that is google.maps.travel-mode.driving, all capital letters like that, because it's a constant. Okay, so like that, what we need to do is pass a second argument here. So the first one is this object here, and the second one is a callback function. So we'll just create the function first, like that. We'll save it so we get formatting. And what we receive here are the result of routing between two locations and the status, like that. So we're only going to sort of act on this if things worked okay. So ideally, we would have error handling and show the user a message, but we'll just assume it worked in this case. So what we're going to do is we're going to say if the status is triple equals okay, and there are results, so just like that, and result, then what we need to do is basically take this result and convert it into the format we want to eventually work with. And what I want is an array where each element in the array is an object, and each object has latitude with the number and long lng with the number. So we want to end up with an array of things that look like that. So to do that, what we'll do is we'll say, let's put it in a variable, so route, and we'll say result. And again, they give you multiple ways you can get from one location to the other. We're going to choose the first one, so result.routes. And then we want the overview path. just like that. So with the overview path, that's an array, but we're going to convert it slightly into sort of the format we want. So we're going to map it, and we'll say each path or each destination along, what we want to do is return. So I'm going to do it shorthand here with brackets, object. We want to return latitude, and we'll say path.lat, it's a function. And longitude, path.lng, it's also a function. So if I save it, we get auto formatting. And why don't we take a look at the result so we can see if we're getting it in the right format. So we've got route. If I come back in the console, we have sort of starting point at this location, and then it's sort of along the way, each corner or each time you need to take a turn, and then you finally end up at your destination, which is the last element here. So there's 10 stops or 10 spots to get from 27 to 75, that address. So now that we have the route, we can call set route, passing in the route, and that will update state. So if we call this here, that will sort of get passed and bubbled up all the way to the top. So now we have the route. And if we wanted to just see what it looks like, maybe we could console.log that. So anytime this renders, we'll just say console.log route like that. It may render a number of times. That's okay. But you can see here that, yeah, every time it re-renders, we have the route showing up here. Perfect. So now our next step will be moving on to taking that route and then actually working with Three.js to draw the path and then animate the car along that path. So in order to get the animation rendered out on the screen, we are first going to call an animation component. So what do we need for this? We need a map and we need the route. And if those are both true, we can render the animation like that. And we're going to be passing to the animation both the map and the route. So we'll pass it as a prop, so map, and then route as route, just like that. So I'm going to place this right here so we can keep it nice and close where we're working, even though it actually gets rendered after the directions. So we'll create the animation here, animation, and we need to receive the map and receive the route as a prop, and then we can do that. So strangely enough, animation is not going to, in a traditional sense, render anything. So we could say render null. So why are we actually using a component? Just so we can take advantage of React's ability to re-render and to watch for changes, to call use effects and things like that. So that's why we're working within a component, and it just fits well to render this when we have the map and the route. And we're going to be wanting to re-render this anytime the route changes. So we're going to set up a use effect, just like this. And we are going to really, what we're watching is anytime the route changes, we want to rerun this use effect. So the first thing we're going to do in the use effect is basically just center the map to where the route is going. So if you look at the screen now, it's centered sort of in the middle of Toronto and Queen's Park, but the directions are sort of down in this area. So let's take the map there. So what we're going to do is we're going to call map, and we're going to say set center. And then to set center, we need to somewhere along that route get the middle point. So this may not be 100% accurate, but what I'm going to do is I'm going to access the route, and then I'm going to say I want the middle point. So the route.length divided by 2. But because that may give us a decimal place, I'll say math.floor to just round that down to the nearest integer, just like that. And whenever we set the center, we can also zoom. So we're just going to change the zoom slightly to be 17, which works for the demo that we're doing. So we'll save this. We'll make sure that it's working. So you can see that it's already centered us down here. When it loads directions, it will take us down here. I wouldn't worry about these errors. it seems to occur because we're working in dev mode within React and it's doing some hot module reloading and stuff like that. I haven't seen them on production, so I think we're fine to ignore those. Okay, so we've centered the map. The next thing we need to do is set up a Three.js overlay. Now I am using a package from Ubi Labs 3JS overlay view to make this a little bit easier to work with. You can do this directly using the WebGL overlay view from Google, but when you use that, you need to set up a few things like the camera, the lighting, the scene, and stuff like that. This package takes care of that for us, so it makes that a little bit easier. And we're going to store that in a ref because we don't want this to sort of cause re-renders. So we're going to say const overlay ref is equal to use ref, like that. So then we can come here, and because we only ever want one overlay, we can just say if there's not one already, so overlay ref.current, then we'll set one up. So we'll say overlay ref.current is equal to, and we're going to create a new instance of this, and it wants to know where to center the map. So we're going to say map options dot center, just like that. Or it's not where to center the map, but it's sort of where to point the camera from. I suppose what we could also do is use this here, but this one works. We just need to sort of tell it where to center itself. So once we have that, the next thing we need to do is tell it what map to attach itself to. So we'll say overlay ref.current, and then we'll call set map on that. And we'll pass in the map. So now we have the overlay. Nothing's changed because we haven't put anything on the overlay yet. So that's what we're going to work on next. We're going to need to access the scene so that we can add things to the scene. And you do that by saying overlay ref.current, and then we say get scene. We call that function here. And the next thing, or the first thing we're going to work on, is rendering that path on the map. And we need to get points because when we're working in Three.js, we want X, Y, and Z coordinates. But all we have right now in the route are latitude and longitude. So we need to convert that. And we're going to sort of take the map, take the route and map it. So iterate over each latitude, longitude, and convert it into the right format. So we'll say we've got a point in the path, and we want to take that P and we want to call overlay ref dot current, and they give us a function called lat lng altitude to vector 3. So to give us those X, Y, Z coordinates, and we're going to pass in P. So if we get that back, and it's complaining because I didn't have an equals, why don't we just console.log what it looks like, points here. So if you come down here, you can see we started with console.log route. We started with latitudes and longitudes, but now we have a whole bunch of vector 3s, which give us the X, Y, and Z is just 0, but it gives us the XY coordinate onto the map. So we're making progress, although we haven't seen that progress yet. So we've got all these points, and what we're going to do is from those points create a curve. So we'll call it curve, and it's a catmull rom curve 3, and we create that from points. So what is this? It's basically a line that runs itself through all of the points you give it. So I sort of imagine an Olympic skier, a downhill skier, they have to sort of pass through all of those flags. And if you were going to look at the route that the skier takes to get down the hill, going through all of the correct checkpoints, that's sort of what catmull rom curve does. Given the checkpoints, create a curve that runs through them all. And from that curve, we can start to work on rendering out the track onto the map or onto the Three.js overview. So we're also going to store this in a ref. So we'll say track ref is use ref. And because this may re-render, we're going to do this little thing where we first to see if there's a previous track already set up. So if there's a track ref.current, we're going to remove it from the scene before we add a new one to it. This is especially an issue when you're doing local development and it's hot module reloading and constantly re-rendering. You can end up with a whole bunch of tracks on your map. So this will help us out here. So we're going to say scene.remove trackref.current, just like that. So now we've got a clean slate and we can create a new one. So we're going to say trackref.current, and that is going to call a function, and we'll call it create track from curve. We'll pass in the curve. So this doesn't exist, so we're going to come down here and just create that. So function create track from curve. It receives the curve, and now we need to go create that. So what do we actually do? We're going to take this curve, and we started with like 10 points or something like that, right? Well, that could sort of lead many gaps or space between points. So we're going to ask the curve for new points, but we're going to ask for 10 times as many. So we'll say curve, give us new points. So get spaced points. And how many do we want? Let's say we want the curve.points.length. So however many there were at the beginning, and we're going to multiply them by 10. So you could multiply by 4 and that would give you a smoother track to run your car along, but I found that for us this works well. So now we need to take these new points and we need to get them in a slightly different format. So rather than sort of the vector 3s, well, let's actually take a look at what they look like. Points. So we have 101 sort of vector 3s now. And in order to draw the line, it doesn't want it as vector 3s, it wants something called positions. So we're going to convert, so from points to positions, and we're going to say points.map. So map each point, take the point, which is a vector 3, and convert it to an array. So that will sort of flatten that out. But then we need to take all these array of arrays, and we need to flatten them. And if you take a look now, positions, we should just have a massive array of positions. So 303 elements of numbers. But you can see that they're x, y, 0 for z, x, y, 0 for z. So we've just done that conversion. With the positions, we can now create a line. So we're going to return that line directly, and we're going to create an instance of line 2. So why line 2 and not line? Well, it turns out that the line that comes from 3 itself, it can't ever have a width to it. You can't make it a fatter line for some reason. There's a bug. I looked into it and I didn't quite understand. But they do give you these examples of something called line 2, which does work and you can make fatter. So a lot of people in their examples end up using line 2 from the examples rather than from the library itself. Strange, but it is what it is. All right, so let's get back to where we were. There's a lot of code here. So the line, the first thing it needs is a geometry, basically where to draw the line. So we'll say new line geometry. And to line geometry, we don't need to pass anything, but then we need to set it from positions. So that's where we're using this big array of numbers here. Anytime you're working with an object in Three.js, typically there's the geometry, sort of what it looks like from a spatial perspective of where on the map it is and how big and its start and stop. But you also need material. How is it going to appear? So we'll create a line material, and we're going to pass in a color. And you'll see in a sec, this is like a yellowish color, but it's FFB703. And I mentioned you can't set the thickness or the line width easily on the line. On line 2, it does work well. So you can set the line width, and we'll set that to 8. And you can figure out what looks good and what doesn't. So create track from a Catmull ROM curve. So if we come back up here, we have placed this in our ref, but it's not in our scene yet. Anything you add needs to be placed into the scene, otherwise you'll never see it. So we need to take the scene and add the track to it. So track ref.current, like that. And I don't think it will quite show up yet. We need to do something small in order for it to work. So what we need to do basically is the Three.js overlay is constantly re-rendering, and we access that rendering loop by overlay ref.current, so access the overlay, and there's an update function. In other places, you may see this called the draw function, but it's the thing that's run every time. And what we're going to do is access the track ref, and we're going to get its material, and we're going to set its resolution, or sort of the right size, and we'll set that from the overlay, the current, because it's a ref, and the viewport size. Get viewport size, like that. This may also not render it quite yet. Ah, it does. Great. Woo. So there we do. But let me just add one line of code that I know we're going to need. We need to ask the overlay, so overlay ref, to request a redraw. Because anytime you're changing things on it, you need to re-render that. The track will never move, but the car we're going to place on the track will move. So we're going to need this in the future. So if I refresh, we get a beautiful track. And if you wanted to, you could change its color. So this is the yellow I set up. You could change its thickness if you wanted it to cover more of the street. But we've rendered it out. That's fantastic. One thing I'm going to do before I forget is, actually, this needs to be inside of update, just like that. But what I'm going to do is return a cleanup function from this useEffect hook. So anytime when a useEffect hook runs, you can return a function, and when a subsequent useEffect is triggered, it calls the prior cleanup method. So you can clean up anything before doing the next thing. And what we're going to clean up is we're going to take the scene and just remove, again, trackref.current. And you may say, Leigh, you did this up here. I'm just being extra cautious. I don't want the track on it if we're going to be redrawing a new track. So good to go. And refresh here. There we do. We have this drawing itself on the map. Okay, so now let's place a car on the map so that we can then eventually animate that car along the track. So we're going to come here. If this here is dealing with the track, this here is dealing with the car or the model. So what we're going to do is we're going to call a function called load model. And this doesn't exist yet. We need to go and create this load model function. So we're going to come down here. We'll just place it right below function load model, like that. And it's an async function because it's going to have some promises in it, just like that. So what we're going to do is we're going to first create an instance of our loader. And loader comes from Three.js, and we're going to be using the GL, the new instance of it, GLTF loader, and we don't need to pass anything to it. But then we can tell our loader to load async. And we are going to load our car from this public folder, low poly car, this scene.gltf file. You can also check out the license of where to find this. And if we come back here, so that would be accessed by low poly car scene.gltf, like that. And this is an async function, so we're going to say, let's get the object and await it to be loaded. And then once we have the object, we'll get the group within it. This might be better off called the model, but we'll stick with object. That's what we're loading. So we ask object.group. A grouping is just you're combining a bunch of different individual pieces. You'll see the car is made up of wheels, of hoods, of windshields and whatnot. So all of those are inside of the group. So if we access that, now with the group, we need to set its size a little bit. Otherwise, it may not show up correctly on the screen. So I've found for this car, it's sort of shrinking it in half. Otherwise, it's a massively large car. But if you're using different models, you may have to work with different scalar sizes. just like that, and we'll return the group. So if we come up, we've got our load model here, but remember it's an async function because it has awaits in it. So it's actually going to give us a promise. So what we're going to do is we're going to say then we can access the model like that, and we need to do something with the model. So very much like the track, we're going to store the car in a ref. So we'll say car ref equals use ref like that. And we're going to double check we don't have two cars. So we're just going to say car ref dot current. We're going to ask the scene to remove the previous car ref dot current before we add a new car. So we're going to say car ref dot current is equal to this model. So what we received from our promise when it resolved. And then we need to take that and add it to the scene. So we can say scene.add car ref dot current, just like that. Okay, so I'm not quite sure if it will, let's see, it looks like I made an error. Group.scale, object.group, error reading, okay. Well, let's go figure out what that is. So we come down here, we await this, and that gives us the object. And then the object, so we're actually asking for the scene is what I think I made a mistake of. So if we wanted to, we could rename this to scene so that it makes a little bit more sense. But the scene is very similar to the group in the sense of it's just a grouping or a combination of everything involved to render the car. We come back. We don't have any errors yet, but the car is sort of nowhere to be seen. So let's work on placing it in the correct position. So what we're going to do, first of all, is because we're going to be animating this car, let's set up a couple variables that we need to both keep track of the animation, but also sort of what a good position is of the car if it were facing forward. And we'll go into that a little bit in a second. So we're going to say animation milliseconds, and we'll say it's going to take 10 seconds or 10,000 milliseconds to complete its path along, its route along the path. And we're also going to set up this variable that I call front vector. So it's a vector 3, and it's sort of, because we're going to be rotating the car in accordance with the angle of the track, we sort of always need a starting point to base that rotation off of. And these numbers here of an x of 0, a y of -1, and a z of 0, I sort of figured out by trial and error. I tried +1, -1. I found this is the one that gave me the angling that I wanted. So we're going to come down here inside of our update function, and we're going to work on animating the car. So first, because the car is loaded async, it may not exist. So let's just check, do we have a car on our map? So carref.current. Okay, so if we do, we need to figure out how far along the path, or what is the percentage that the car has traveled. So we'll call that the progress. So our progress, what we can say is, we're going to use a function from JavaScript called performance, which gives us the time, and we can get the modulus, so the remainder, using how long we want to animate. And then if we divide that by the time we want to animate, it gives us the percentage of how much of the animation it has completed. So why don't we just render progress out, and let's see what it's doing. Let's make sure that we've got this number showing up. Okay, so you can see it's sort of 30%, 40%, 50%, 60%, and once it gets to 100%, it kicked back to 10%, 20%. So it would be animating. That's the progress right there. So once we have the progress, or how far along, we can ask the curve to get the point at. So if you're 50% through the curve, what is the point at that level of progress? Or if you're at 1% or 99%, give me the point that corresponds to that percentage of progress. And then we can copy that point into the carref.current position. So the second parameter here, it copies the point into where the car is. So if we reload now, we sort of have the car going along the path, although it's hard to travel in this car when it's on its nose like that. But that's where we got to now work on rotating the car in the correct way. So first things first, if I just take the car, so carref.current, and we rotate the x-axis, and it wants an angle, and the angle that I found works for this is pi divided by 2, which I believe is a 45 degree or 90 degree, but you can play with that. So if we reload, it's sort of doing weird things. It's going a bit haywire. But I think if we apply this next thing, it's constantly sort of flipping itself around. But if we apply this other rotation to keep it in line with the path, this one will make a lot more sense. So why don't we keep that there like now, and we'll add it back in a second. But what I wanted to do before I forget is to just do the scene cleanup of the car. So we'll say carref.current like that. Okay, so now what we're going to do is try to rotate the car in accordance with where it's at along that curve. So we can say carref.current, so access the carref. And one of the ways that you can rotate things in 3D space is called a quaternion. I've looked at the Wikipedia page, and to be honest, it's a little past my understanding, but it gives us a function of set from unit vectors. So basically, rotate it according to 2 points. The first point that we're going to use is this front vector, or the front of the car. So we'll come down here and we'll say front vector, and then rotate it according to where we're at along the curve. So get the tangent, or the angle, at the level of progress that we're at. So given these two things, we can come back here and refresh. And the car is now traveling along the path, and you can see it that it's turning itself when it gets to the corners. So now if I reapply this animation right here, and we just refresh, we've got it animating along the track, and it's turning along the corners, and it's always restarting once it gets to the 10-second animation. So it starts, it's rotating, and then it's starting again. So we've got where we wanted to end up. If we just rehash what we've done, there's a lot of lines of code here. We're at almost 180 lines of code. But if we just break it down, sort of starting at the top, we loaded the Google Maps script. From that, we could render the map onto the screen. And once we have the map loaded, we could render our directions. And the directions not only displayed them, but it called the direction service to get sort of the points to get from the origin to the destination. That got passed up back here in state in route. And then given the route, we could then do the animation. So then what the animation does is it first starts by creating a Three.js overlay. And then onto that overlay, we could place the track, which was based on the points and creating a Catmull-Wrong curve. And then we added that to the scene, which is sort of what's visible onto the Three.js overlay. We loaded our car model and placed that onto the scene as well. And then we took care of every time it refreshes. So every time it re-renders, which is typically either 30 times a second with 30 frames a second or 60 frames a second. And we're constantly taking the car and repositioning it along that curve, given the percentage of progress it's made, 10 seconds to start from beginning to end. Hope you enjoyed this video. You saw a lot of neat functionality that I enjoyed playing with a lot. Take care. Bye.